The second target for this unit was the periodic table and how it organizes some of the properties that we learned about in target number 1. One of the ways that the periodic table organizes the elements that make up all matter in our world is by atomic number. This is how it was originally organized, and this still holds true today. The atomic number is how many protons does a particular atom have in its nucleus. No two elements have the same atomic number. For example, carbon has 6 protons in its nucleus, and it has the atomic number 6. Oxygen, on the other hand, has 8 protons in its nucleus, and so therefore it has the atomic number 8. So the periodic table will organize these elements from increasing atomic number, meaning it starts with number 1 and then it moves from left to right and down as you increase in the atomic number by 1 proton. Now, there's some other things that the periodic table can show us as well. It can show us relationships between elements. It can also tell us some chemical and physical properties simply based upon its position. And that's the stuff that we looked at in 7th grade this year about how does a periodic table organize elements more so than just by atomic number. So the first thing we did is we started off by looking at each element's elemental square. So we wanted to decide what type of information does this element square show us. So we talked about the first thing was the atomic number, the main way that you can tell the difference between each element. The atomic number is always located at the top of the element square. And once again, that tells you how many protons are in the nucleus of an atom. Below that, it talks about the chemical symbol. The chemical symbol of most elements correlates with their name. So, for example, carbon starts with a C, so the chemical letter symbol, or the letter it's used to represent that element, is C. Unfortunately, some of the elements are hard to find a correlation between their symbol and the actual elemental name because some of the symbols are based upon that element's Latin name as well. So here we have copper. You can't use C because carbon already uses C. You can't use CO because cobalt already has the chemical symbol CO. So what they've done is they've used Cu, which is based upon copper's Latin name. Underneath that chemical symbol, you will see the atomic mass. The atomic mass will tell you how many protons and neutrons are in the nucleus of that particular atom. So, for example, hydrogen has the atomic number 1. Well, we know it has 1 proton because of its atomic number, which means that hydrogen does not have any neutrons in its nucleus. So you can actually use this number as well as the number of protons or the atomic number to figure out how many neutrons are present in the nucleus of that atom. Not every nucleus is going to have the same number of protons as neutrons. Another thing that we looked at is not just what it shows us in the element square, but also how does the placement of an element tell us a little bit more about it. So for example, this atom right here has 1, 2, 3 electron shells or energy levels. This atom would be placed in row or period number 3. So I have row 1 here. Row 2 is the bluish color, and then finally row 3 is back to that lime green color. That element that is showing right here would be somewhere in row or period 3 because it has 3 energy levels or electron shells. I would know anything in this row right here would have 4 electron shells. So if I scroll down, you will see that in total, all elements are going to have anywhere between 1 electron shell to 7 electron shells. Row 2 would have 2 electron shells, row 3 would have 3 electron shells, and row 4 would have 4, and so forth. Once again, rows are not always called rows. Rows are called periods on the periodic table. Another piece of information we looked at based upon where it was located is what family or group would that element be in. Now, elements that are in the same family or group, or also known as vertical columns, have more in common with each other than any other element on the periodic table. So if I look, here is column 1. All of these particular elements are extremely reactive. because they have one valence electron or one electron in their outermost shell. So because they're so close to having a full outer shell, they are desperate to react and lose that one electron. So they are willing to react with anything that will take that one electron. Over here, column 17, or for our purposes, we called it 7A, these are highly reactive nonmetals called halogens. They are desperate to react because they want to gain one electron. If they gain one electron, then they will have a full outer shell. Group 18, or 8A, is known for being the most unreactive elements on the periodic table because all of these particular elements have full outer shells, and so they are happy just the way they are. They don't want to gain or lose any electrons. So the elements in this column are more similar to each other than they are to any other element, including an element that's in the same period as them. So for example, this element right here, it would be more similar to the one above it or the one below it than it would be to the one right to the left. So these in the same column are more similar to each other than anything that's in the same row. The only thing that an element in the same period or row shares or has in common is the number of electron shells that they have. And so we went through, and once we determined what the rows and the columns or the families and the groups told us, we determined that there were some elements that had very, very common properties that we wanted to learn about. So 8A, we called those the noble gases, and those are highly unreactive or non-reactive elements. They're also called inert gases, which means they do not want to react at all. Another thing that we looked at were the alkali metals, which are in group 1A. They're grouped together because they are so reactive. And what's weird about group 1A is it is the only metal column right here that has a nonmetal in it. And that nonmetal is hydrogen. It actually has properties that are more nonmetallic, and it should be over here with the rest of the nonmetals on the right-hand side. But because it has one valence electron or one electron in its outermost shell and how extremely reactive it is, it gets placed over here with the other elements that have one valence electron. And then finally, right here was our halogens, our highly reactive nonmetals. And you can even see at the bottom, one of those nonmetals is actually considered a metalloid. But they're all in the same column because of their similar chemical and physical properties with one another. If I were to go to the Mastery Connect pre-assessment that we did just recently, question number 2 said, which of the following groups contains the most reactive elements? And we said the most reactive elements on the periodic table are those that have their electron shells almost filled. Now, the noble gases, D, were the ones that have their electron shells filled, and they do not want to react at all. So that was not the correct answer. Carbon is one of those that has its shell halfway filled. So it wants to react, but it doesn't matter if it gains or loses electrons. So it's not really as reactive as a lot of the other ones on the periodic table. The group that we read about that were highly reactive was the alkali metals. Those are the group, that is the family of 1A or column 1A, and it has one valence electron. So it's desperate to get rid of that one valence electron so it can be considered stable. Another question from the pre-assessment said, from an element's location in the periodic table, you can predict, well, based upon its location, we know how many valence electrons it has based upon the column it's in. We know how many electron shells it will have based upon the period it's in. And we know that we can predict a lot of its metallic or non-metallic properties based upon if it's located on the right or the left-hand side of the periodic table. So the correct answer was, based upon its location, we know some of its properties. Another one that we talked about was atoms in the same column or family have the same number of electrons in their outer energy level, known as valence electrons. So this one, D, was true. And finally, 6, atoms in the same period of the periodic table had one thing in common, and that was the same number of electron shells or energy levels. So those were some of the properties that we looked at on top of just looking at the information that the element square